P0306 on this Ram 2500HD with the 6.4HEMIGas engine means the PCM is seeing a cylinder 6 misfire pattern. The truck may run rough, hesitate, flash, or turn on the MIL, and stop/start may be disabled while the fault is active. Broadly, this can come from ignition, fuel delivery, air leaks, engine mechanical issues, oiling or valvetrain concerns, wiring, connector problems, or the PCM's control side. The important thing is not to guess at cylinder 6 parts. Work the misfire in order and prove where the fault is. Start with the basic system checks. Then turn the ignition on, read and record all codes and captured operating data, and try to reproduce the same conditions that set P0306. During the road test, note exactly when the misfire shows up, because that matters later. Watch the downstream oxygen sensor behavior while the misfire is occurring, and use the misfire monitor to confirm cylinder 6 is the cylinder counting excessive misfires. If cylinder 6 is not misfiring now, treat it as an intermittent condition instead of forcing a diagnosis that is not active. While the misfire is present, the downstream oxygen sensor can give you direction. Readings consistently low point toward a lean condition or lack of fuel, such as a plugged injector or fuel system issue. Readings consistently high mean the catalyst is being loaded with too much fuel, which can happen from lack of spark or a leaking injector. Also remember that during a severe flashing MIL misfire, the PCM can shut off the affected injector to protect the catalytic converter. So a high load or high RPM misfire may look like it continues at idle until the reset strategy catches up. Next, look at the other recorded codes without turning this into a code list. If there are active or pending faults in the fuel system, ignition system, air handling system, VVT system, or VVL system, handle those diagnostic paths first. If not, keep going on the cylinder 6 misfire path. With the ignition off, inspect the MDS solenoid harness connectors, jumper connectors, and terminals. You are looking for poor seating, damaged locks, corrosion, water intrusion, seal damage, bent or pushed back terminals, spread terminals, overheating from a poor connection, and weak terminal tension. If you find a connector or terminal issue, repair that condition and verify the repair. If that area is clean, move on. Now do the bigger inspection. Check for belt wear, pulley misalignment or binding, improper sensor mounting, poor connector contact at key engine components, weak PCM power or ground connections, vacuum leaks, intake or exhaust restriction, signs of internal engine trouble, moisture on ignition parts, fuel supply or fuel quality concerns, and load-related complaints such as bogging or towing overload. Anything that can disturb crankshaft speed can set a misfire code, so this is where you catch the obvious causes before going deeper. Repair what you find and verify. If nothing stands out, continue. Check the engine and intake manifold for vacuum leaks. If the intake system is leaking, repair the leak and verify. If not, check the fuel for water, wrong fuel type, old or contaminated fuel, and low fuel. Also check for proper ethanol level in the gasoline. If the fuel is bad, replace the fuel, and if needed, flush and clean the fuel system, then verify the repair. If the intake and fuel quality both pass, go to injector balance direction. Before touching fuel lines, release fuel system pressure. The fuel system stays under constant pressure even with the engine off, and mishandling it can cause serious injury. Install fuel pressure decay tester 8978A at the fuel rail. Turn the ignition on, let pressure reach maximum and stabilize, and record that as the starting pressure. Command the cylinder 6 injector with the scan tool while watching the gauge, then record the ending pressure. Repeat the same test on several known good cylinders, starting each injector actuation from the same starting pressure. After each injector actuation, start the engine to clear fuel from the cylinder, because failing to do that can damage the engine. Compare cylinder 6 to the known good cylinders. If the ending pressures are about the same, keep going. If cylinder 6 stands out with too small a pressure drop, check for debris in the fuel rail or injector and repair as needed. If the drop is too large, Suspect a faulty or fouled injector, then verify the repair. Turn the ignition off, remove the fuel pressure decay tester and reconnect the fuel lines before continuing. Remove the ignition coil from cylinder 6, reconnect the coil harness connector, disconnect the fuel injector connector for that cylinder, and install a spark tester on the coil. Crank the engine and watch the spark tester. If you have a crisp blue spark, continue with the plug and cylinder checks. If you do not, skip ahead to the ignition feed and control circuit checks. With the ignition off, remove the cylinder 6 spark plug and inspect it closely. Look for cracks, carbon tracking, oil fouling, coolant fouling, excess fuel, incorrect gap, or a loose or broken electrode. Also look for signs of oil or coolant in the cylinder. If the plug has one of those faults, replace the spark plug using the correct repair procedure. If oil or coolant is present in the cylinder, diagnose and repair that root cause before calling the plug the fix. Then verify. If the plug and cylinder inspection pass, move to compression. Run a compression test on all cylinders and compare cylinder 6 against known good cylinders. If compression is not within specification, perform a cylinder leak down test to decide whether the loss is coming from the valvetrain or combustion chamber. Repair as needed and verify. If compression is within specification, swap the cylinder 6 spark plug with a known good cylinder, or replace the plug if access makes swapping impractical. Start the engine and watch the misfire monitor. If the misfire follows the plug or disappears after plug replacement, the plug was the issue and the repair gets verified. If the misfire stays on cylinder 6, decarbon the engine with MOPR combustion cleaner, drive it to clear the cleaner, erase the codes, and test drive under the captured conditions. If the misfire does not return, the valve and combustion chamber cleaning repaired the fault. If it returns, keep going. Next, check engine oil level and condition, along with mechanical and oiling concerns that can affect valvetrain operation. Look for engine mechanical tolerances out of specification, oil pressure out of specification, low oil level, the wrong oil filter, deteriorated or dirty oil, contaminated oil, incorrect viscosity, or aerated oil. If any of that is present, repair the oiling or mechanical issue and verify. If the misfire happened when engine speed exceeded 5,000 RPM and VVL is suspected, check VVL operation, including solenoid O-rings and leakage when the solenoid is off. There is a cylinder mapping concern in this part of the path. The VVL description identifies cylinder 1, not cylinder 6, so do not assume the cylinder 1 rocker detail applies to this P0306 fault. Pause, recheck the earlier diagnostic path, and avoid guessing. If VVL checks do not explain it, inspect the camshaft lobes, rocker arms, and springs for excessive wear or broken parts. Repair any confirmed valvetrain issue and verify. If no issue is found there, move to the final harness and PCM connection checks. If the earlier coil test did not show a crisp blue spark, go into the ignition circuit branch. Keep clear of the fan, belts, pulleys, and loose clothing anytime the engine is operating. With the ignition off, disconnect the cylinder 6 ignition coil connector. Turn the ignition on, command the ASD relay with the scan tool, and use a 12-volt test light connected to ground to check the ASD relay output circuit at the coil connector. If the light does not illuminate brightly, stop scan tool actuations. Repair the open or short to ground between the PDC and the ignition coil connector and verify. If the feed is good, use a 12-volt test light connected to a 12-volt source, backprobe the coil control circuit at the coil connector, and crank the engine for 5 seconds. A bright blinking light means the control circuit is being pulsed, so replace the ignition coil and verify. If the light stays on constantly, check the coil control circuit for a short to ground. If the light stays off constantly, check the coil control circuit for an open. For a control circuit short to ground check, turn the ignition off, disconnect the PCM-C2 connector, and install the GPEC Diagnostic adapter 10436 on the engine harness side. Do not probe the PCM harness connectors directly, because that can damage the terminals and create a poor terminal-to-pin connection. Check continuity between ground and the coil control circuit at the ignition coil connector. If continuity is present, repair the short to ground and verify. If not, continue to the final connection checks. For an open circuit check, measure resistance in the coil control circuit between the ignition coil connector and the GPEC adapter. If resistance is below 3.0 ohms, continue to the final connection checks. If it is not below 3.0 ohms, repair the open or high resistance in the coil control circuit and verify. For the final electrical pass, disconnect the PCM connectors, any related inline connectors, and the related component connectors. Inspect the connectors and terminals for seating, lock damage, corrosion, water intrusion, seal damage, bent terminals, overheated terminals, push-back terminals, spread terminals, and terminal tension. Repair anything found. Then reconnect the PCM, inline, and component connectors, making sure everything is fully seated and locked. Erase the codes, operate or test drive the truck under the monitor conditions, and read codes again. If P0306 does not return, the wiring or poor connection problem has been repaired. If P0306 does return after those checks, replace and program the PCM, then verify the repair. Keep verification separate from testing. The misfire monitor is gated by conditions such as fuel level above 12%, battery voltage above 10.9 volts, ambient temperature above -23 degrees C, -9, 4 degrees F, coolant temperature at engine start above -7 degrees C, 19, 4 degrees F, or enabling when engine temperature reaches 21 degrees C, 69, 8 degrees F, and engine speed between approximately 400 RPM and 6,200 RPM. The code sets when crankshaft speed variation between cylinders exceeds a calibrated value for engine speed and load. So the takeaway is simple. Prove the cylinder 6 misfire is active. Use oxygen sensor and misfire data for direction. Check fuel, spark, compression, carbon, oiling, valvetrain, and wiring in order. And only make the PCM call after the harness and control circuit checks are complete. For more diagnostic training, visit stepdiagnostics.com.